All right, so we are going to look into now using these trigonometric functions to solve for triangle sides. Now, this is in cases where they are giving us actually some angles. So now we're going to see kind of the power of trigonometry and and how it can be used in these situations. All right. So the learning target is you can use trig ratios to solve for the sides of right triangles. We're going to talk about some special right triangles that have exact values of trig ratios, and then we'll just do some general solving for side cases and kind of going back and forth between them actually. So we are going to just jump right into the special right triangles now, okay? So what this says is some angles are so special that you can find sine, cosine, and tangent without using a calculator, right? So these are ratios that are kind of like sort of like industry standard. Like these are common things. And so the two triangles we have is we have a 45, 45, 90 triangle. All right. So this is basically it's an isosceles triangle. All right, and it's just turned the other way, but it's a kind of isosceles triangle where it has a right angle at the top, right? And then meaning these are 45 degrees here. So the ratio it has is the hypotenuse is always the square root of 2 times bigger than x. So it's like 1.2 or whatever it is bigger than this, right? So it's bigger than it, not vastly bigger than it, but bigger. And then you have a 30, 60, 90 triangle, all right? And the side that is between the hypotenuse and the 30 is the long leg, and that's x times the square root of 3. And then the side that has the 60 degree is the short leg, and that's just x. And then your hypotenuse is twice the length of that side. Okay, so they can use these and manipulate these and turn these things around and use them to kind of solve problems. So we're going to look at what are the exact ratios first of all. All right, so we're going to do all the ones with this one first. All right, so we've got the sine of 45 degrees. All right, so if it doesn't matter in this case which one we do because the angles are the same. So we'll just use this angle. All right, and we'll say okay, we're going to find the sine of 45 degrees. Okay, so sine is sine of 45 degrees is going to be the opposite side over the hypotenuse. So it's x over x times the square root of 2. Okay, and so what this gives us, right, is our x's cancel, and you get 1 over the square root of 2. And I got the 1 from the fact that these cancel, but you got to put something up there. So it's basically x divided by x is 1. So it leaves a 1 up there. So you got 1 over the square root of 2. And hopefully you remember that you can't leave the square root on the bottom. So we're going to just multiply this by the square root of 2. And you get square root of 2 over 2. And that is the ratio for sine. Now, cosine is going to be basically more of the same, right? Because the cosine, if we use this angle, cosine's adjacent over this, well, they're the same, right? X, x, right? So you're going to get exactly the same thing. So you're going to get square root of 2 over 2. And then your tangent is, I'm going to write this down and just say same, right? Your tangent of 45 degrees is your opposite over your adjacent. Well, they're both the same. So you get x over x, which is equal to 1. So your tangent is 1, right? It's exactly 1. And that's what you get. And that makes sense because if you have two sides and they're exactly the same length, which these are, then you're going to get 1. All right, now this one presents like some more interesting looks, right? So we're going to do our 30-degree options first of all, okay? So you got the sine of 30 degrees. So that's the opposite, which is this one, over the hypotenuse. So you have x over 2x. Your x's cancel, so that leaves you with 1/2. So the sine is 1/2, all right? Cosine is going to be x times the square root of 3. Why did I write 2? I don't know why. X times the square root of 3 over 2x, okay, because it's the adjacent. This is the adjacent over the hypotenuse. So your x's cancel, and you get the square root of 3 over 2, which is it's more than 1/2, but it's less than 1, right? Because square root of 4 would be 2 over 2, which is 1, so it's smaller, right? So it's square root of 3 over 2, and then your tangent is going to be your opposite, right? Am I right? Tangent is opposite over adjacent, and in this case, the tangent of 45 degrees, or 45. What am I talking about? The tangent of 30 degrees. All right. Well, the opposite is x over x times the square root of 3, right? So you got x over x times the square root of 3. So we're going to get another case where we're going to have to rationalize something. So let's do this. We'll put this here. So we're going to have 1 over the square root of 3. We're going to multiply both times the square root of 3. And you get the square root of 3 over 3 is your tangent. Okay, so these are our all of the trig ratios using 30 degrees like as your reference angle, right? And so now we're not going to use 30 degrees anymore, and we are going to use 60. We'll use this one. Okay, and so I'm gonna erase this stuff right here, and we're gonna do this. I'm gonna try and work a little more neatly for you guys. All right, so when you do your sine, right, sine of 60 degrees is opposite, which is x over the square root of 3, because it's the opposite one, over adjacent. So it's x over the square root of 3 over 2x, right? So your x's cancel, and you get square root of 3 over 2. So I think you can kind of see where this is going. When we do cosine, make a prediction and see if you know what we're going to get, right? Cosine of 60 degrees, it's x over 2x, because this is your adjacent side, and that's your hypotenuse. X over 2x gives you 1/2, because your x's cancel. And then the tangent of 60 degrees is going to be a little more agreeable this time, right? So we are going to have the opposite, which is x times the square root of 3 over x. Your x's cancel, and you actually just get the square root of 3, right? So these are our the ratios, right? And so when we look at things like this, we're going to use these ratios to help us, right? Kind of solve it. And remember, we'll write these as ratios, and we'll compare them with other ratios. And when we do that, you always think of anything with a whole number that's a trig ratio is just over 1. So this would be like, square root of 3 over 1. I mean, we don't write it like that, but we should know and remember that that's kind of the case, okay? And so I know for myself, I need a lot of times to kind of remember these and how these look, right? These aren't super obvious to me. So you'll have this to reference and to look at, and we'll probably bounce back and forth on it when we do the next problem. So these are the special ratios, and we will see you in the next video.